Okay, here we've got the GCSE past exam question. There are 5 red pens, 3 blue pens and 2 green pens in a box. Gary takes at random a pen from the box and gives the pen to his friend. Gary then takes at random another pen from the box. Work out the probability that both pens are the same colour. Now, you can model this by using something called a tree diagram. Which I'm going to do for you now. So, just fix my camera. Okay. So, we've got 3 pens in the box, 3 different colours in the box. We've got 5 red, we've got 3 blue, and 2 green. So first of all, we need to work out the probability of picking one of these colours on the first pick, or selection if you like. So Gary's going to take out 2 pens. So, I'll start it off. Because there's 3 outcomes, we can draw 3 stalks, if you like, or branches. Okay, we've got red, blue, and green. And this is our first pick or selection. Okay. So because there's 5, how many are there altogether? We first need to work out the probability of picking each of these colours on the first go. So there's 5 out of 3 add 2. So there's a 5 out of 10 chance it's going to be a red. There's a 3 out of 10 chance it's going to be a blue. And a 2 out of 10 chance it's going to be a green. Okay, just going to rub this out. Now we need to work out the probability of what will be picked on the second go. Now remember, we've already picked out one colour. We've already picked out one pen or one colour. There's not going to be 10 pens left on the second go or on the second pick. There's actually going to be only 9 left. So if we picked a red on the first go, there'll only be 4 red pens left out of the 9 remaining. But however, if we picked a blue on the second go, that would be a 3 out of 9 chance, because there's still 3 blues left. So here, if we picked red on the first go, it would be a 4 out of 9 chance we pick red on the second go, 3 out of 9 chance we pick blue, and 2 out of 9 chance to pick green. You can always check whether your probabilities are right, because they should add up to 1. So 4 ninths add 3 ninths add 2 ninths is 9 ninths, which is a whole. Okay, and I just forgot to write green here. Okay, so now let's say we picked blue on the first go. So red, blue, green again. Okay, if we pick blue on the first go, there'll still be 5 reds in. So it'll be a 5 out of 9 chance to pick red on the second go. There's only 2 blues this time, so there'll be a 2 out of 9 chance I pick blue. And there will be a 2 out of 9 chance I pick green. And then finally, if we picked green on the last go, so this all looks a bit stacked. Let's move this up a bit. If we pick green on the first go, there'd be 5 reds left out of 9. There'd be 3 blues left out of 9, and there would be only 1 green left out of 9. So, what the question is asking us to do are work out the probabilities that the pens are the same colour. So what we need to look at are the probabilities of picking a red and a red, a blue and a blue, green and a green. Now, two different events the probability of something happening on the first go and the second go will be multiplying the probabilities, not adding them. So probability of picking a red and a red, I'll put some outcomes here. So red and a red would be 5/10 times 4/9. A blue and a blue would be 3/10 times 2/9. So just notation here, probability of a red and a red, probability of a blue and a blue. And now the probability of a green and a green would be 2/10 times 1/9. So that's the probability of a green and a green. Okay. So going forward, that's what we need, that's what we need, and that's what we need. Okay, so what we need to do is now simplify these. Then after we simplify them, we need to add them together because they are mutually exclusive events. Okay, so they're not impacting on each other, they're not dependent on each other. So 5/10 times 4/9, so the probability of a red and a red would be 5 times 4 is 20, over 10 times 9 is 90, so 20 over 90. And then we've got probability of a blue and a blue. 3 times 2 is 6, 10 times 9 is 90. And probability of green and a green, we're running out of space here, equals 2 times 1 is 2. 10 times 9 is 90. And then what we do, we need to add these three probabilities together. So when you're adding fractions, if your denominators are the same, you can just add the numerators. So 20/90ths, add 6/90ths, add 2/90ths, equals 28 over 90. And that's our probability that the pens are the same colour. It's not asking me to simplify, has it? No, so I can just leave it as 28 over 90. But just to recap, look how I structured those outcomes. Okay, I've got my first pick, my second pick, and just remember, once one pen is gone, the probability changes to out of 9 and not 10. Okay? And the probability of both of these things happening, so red and the red, it'd be multiplying those probabilities together because those events are dependent on each other. So that's why we're multiplying. Okay. And then after that, we've worked out the probability of these of the pens being the same colour. We then add the probabilities together, like so.